All right, I got what you got here is there's three different graphics, and I'll show you what today's looks like so that you can use it to find the stuff on YouTube. One of the things that happened on YouTube, and like 4 or 5 of you, or 4 or 5 of my students have just gone ahead and subscribed to the channel. I'll show you how to do this later. If you go to my webpage right there in the middle and you click on watch the video on YouTube, the whole playlist comes up. By the time we get finished, the playlist will have about 14 or 15 things on it. As of right now, it has the Chapter 1 review, the second review, which you got back today, and some stuff on point graphs. You'll also notice there's a new video on there that we may or may not have time to watch today. If we don't, it'll be tomorrow, on even and odd functions. As an even and odd function is something entirely different than you would think of with even or odd. With even and odd numbers, you know what makes an even number or odd number is the fact that it's divisible by 2. What's 0 divided by 2? 0. There's no remainder. Therefore, 0 is an even number. 2 goes into 8 4 times with no remainder. That means 8 is an even number. That's what it is that makes a number even or odd based on whether it's divisible by 2. That is not nowhere close at all what makes a function even or odd. Okay? And we'll talk about, like I said, probably more tomorrow, but functions being even or odd is something that shows up in this review. We didn't spend a lot of time on it first semester. Matter of fact, I think it was on a poster up there, but beyond just identifying a couple of them as even or odd, we didn't spend a lot of time on even or odd functions. I would hate for one to show up and me not at least have mentioned it for you. Like I said, I'm going over the answers from yesterday, and then if you want to get these videos, they're on my YouTube channel. Okay? The biggest mistake that we made with this stuff is you guys would write the work down and your work was great, but you didn't write the answer. And hopefully you circle it on your sheet or something like that. But guys, not writing the answer, we kind of are missing the point. Okay, in this problem right here, you extend the line on, and you notice this line has a slope of, we'll find that in a second, but more importantly, a y-intercept of 5. And if you find a lattice point and go from one point on the grid to another point on the grid, the slope was 1. So then you look down here and you notice that because the lines are dotted, this is a greater than or less than is dotted line. So this is a greater than problem that has a slope of 1 and a y-intercept of 5. So you find the slope of 1 and y-intercept of 5, and you notice there's a couple of answers there that have that. So then all it is a matter of looking at the second equation. Well, the second equation has a y-intercept of 1 and a slope of -1. So the one that has a y-intercept of 1 and a slope of -1, a lot of you guys wrote this out. You wrote this work right here out, and you said both of these were greater than, so they were both shaded above, but you just didn't put A. I still gave you credit for it, guys, but let's understand again why we're doing this EOCT, guys, is to help us prepare for the EOCT, and it's going to be multiple choice. Guys, I don't want you to look at this right here and go, oh, the y-intercept is 2, the slope is 1, down to the answer, circle it up. Because they're going to have distractors down here of things it is they're trying to, so on every problem, guys, you can identify something. It crosses the y-axis at -2. The one of these that has it crosses the y-axis at -2, guys, there's only one of them. Look, there's no way any of the other 3 can be the answer. So the only one logically, what I don't want you to do is circle this one, forget about it, and go on. Because you could have made a mistake in identifying your -2. So go ahead and make sure in a problem like this, because this is one, guys, we got to get it right. So the slope is 1, and that holds true with the answer of C. What I'm trying to help you with here is how you go ahead and take an EOCT. Again, same concept. Don't plug in 1 point and go, hey, 1 point works, so what does it matter that I try the other problems? So if I plug in 1 plus 1, I get 2. That one doesn't work. 1 plus 2 is 3. That one doesn't work. 2 times 1 is 2, minus 1 is positive 1, so the answer's got to be D. Be careful doing stuff like that, guys, because you could make a mistake trying 1 point. But if you try a bunch of points, you're going to be better off. 2 times 3 is 6. 6 minus 3 is 3. 2 times 4 is minus 5 is 3. 2 times 5 is 10. Minus 3 is 7. I also want you to notice this, guys. Look, the rise, which is the change in y, over the run, which is the change in the x values, guys, the change in x, and the definition of change in y over change in x is the slope. Okay, so it's 2. Guys, all that happens is phone go. Let's go. Come on, work through it. 2 over 1. So the slope is 2 over 1. Again, if you look, only 2 of these problems has a slope of 2 over 1. So that kind of, you messed up. Because that doesn't work every time. See, so what I'm trying to get you to see is the distractors are made up to have something about them to be true. So the one that works is D. A lot of you had the work where you even plugged in all the points. Somebody, I can't remember who it was, you said 2 times negative 1, 2 times 1 minus 3 is negative 1. You wrote 6 equal sign, but you never said D. Again, guys, make sure we're doing the answers for it. Here's a problem. Just looking at this, when I draw my line in here, I notice it has a y-intercept of negative 1. It has a slope of up 2 and over 1, up 2 and over 1. So the one of these equations that has a slope of 2 and a y-intercept of negative 1 is A. Again, a common way to ask this question is not to ask you the slope of this line. They're not going to give you an equation like this a lot of times. They'll give you an equation like this and ask you the slope of the line parallel. Remember, if they said the slope of the line parallel, you know that parallel lines would have the same slope, so the other equation would have to have a 2 of the slope. If they said perpendicular slope, what's the slope of the line that's perpendicular to this one? If this is 2 over 1, the perpendicular slope would be good, negative 1/2. Again, the way I found perpendicular slope is I take these 2 numbers right here, I do 2 things to them. I flip those 2 numbers and make it negative. Because if you miss this one, I'm kind of struggling with you being able to read the problem, because right there's the points. It says, based on the table, which has the common points. So, again, this was one of those things I talked about yesterday. Probably a better question, a question that finds out more, is that they give you these 2 tables right here, and then they might ask you what the categories of the system was. So, name this system. Is it consistent and dependent? Is it consistent and independent? Or is it inconsistent? Well, based on what we had yesterday, guys, the single conversation that's going on should be up here. Based on the conversation that we had yesterday, it's consistent. The reason it's consistent is because it has solutions. How many solutions does this thing have? 1. Guys, it doesn't have 2. There are 2 parts to the solution. because the two parts, the two coordinates, 2, 3, represent the one point where these two lines intersect. So it's a consistent and independent system. Because we seem to be struggling with this concept, guys. There's not but 3 issues. 3. Not 15,000. There's 3. I 100% guarantee you, if I brought 3 different animals in here and set them up here, every one of them could point to which and probably name them all. You started out when you were a little kid with the little thing that pulled and went around and stuff like that. The same skill is necessary to identify systems. But you have to know what it is that makes each one of those things what they are. A consistent and independent system has one solution. A consistent and dependent system, they're right on top of each other and they have infinitely many solutions, which brings us to parallel lines, which have how many solutions? None. So it's inconsistent. Right? Guys, it's basically the same exact problem 5 times. It's a matter of 3 times. It's a matter of picking out the points that work the equation. Today's first question, look at today's first question. It's a completely different type question, but it's the same concept. What you have to do is identify the points that work. So you identify the points that work here. 3 times 4 is 12 plus 5 is 17. 3 times 3 is 9 plus 14, 3 times 3 is 9 plus 5 is 14. Again, the slope is 3, which tells me these numbers should be going up by 3, while these numbers are going up by 1. Guys, it's true. If I went to the next point, the next point up here would be 0, 5. 0, 5 is the y-intercept. So that's why this answer is D. Again, guys, make sure you give me what the answers are. Y'all did a much better job this time with writing work down, but you did a much worse job of giving the answers. As y'all would write the work and all you didn't write that thing. But remember now, what I don't want you doing is taking the computer, seeing the problem on the computer, never picking that pencil up, just bouncing your mouse around and writing it.